So guys, having understood the basics of loopback IP address, next we will try to learn that how does L3 routing happens when destination IP address in the IP header of the packet is actually the loopback IP address of the destination machine. Till now we have seen the examples of L3 routing where destination IP address in the packet actually belongs to the IP address of one of the local interface of a destination machine. So how routing happens when destination IP address in the packet is actually the loopback IP address of the destination machine? Is there any difference? Let us see how routing happens in this case. So let us do a little recap here. Let us suppose the destination IP address that is specified in the packet is 192.168.1.3. That is, the packet is destined for the host machine C placed somewhere in the network. So let's say that L3 router A receives a packet with destination IP address is equal to 10.168.1.3. Right? So router A will forward the packet as usual using L3 routing. The packet goes in the internet, and internet is nothing but it is a complex topology of hundreds of L3 routers. So let us say that all those L3 routers present in the internet routes the packet, and let us suppose that the packet eventually reaches the L3 router B via L3 routing. Right? Now what will happen once the packet reaches the L3 router B? So let us apply the concepts of L2 routing and L3 routing we have done so far. So router B will inspect the destination IP address in the packet, and it will see whether the destination IP address that is specified in the packet belongs to one of its local subnet or not. Now you can see that router B has 6 local subnets, right? So this is one local subnet, this is another local subnet, and you can see that router B has 6 local interfaces, and therefore router B has 6 local subnets. It so happens that the destination IP address that is specified in the packet falls in the subnet 10.168.1.0/24, right? So now router B knows that the packet is destined to a machine which is present in its local subnet on interface Ethernet 1. So from here onwards, router B will use L2 routing in order to deliver the packet to the destination machine C. So when the packet leaves the router B, the source MAC address, destination MAC address, source IP and destination IP address in the packet is somewhat look like this. That is, the source MAC address in the packet will be equal to the MAC address of Ethernet 1 interface of the router B, and the destination MAC address will be the MAC address of the host machine C, which is the destination of the packet. Source IP address here is irrelevant. You can assume any value of the source IP address and it will remain unchanged throughout the packet journey. And similarly, the destination IP address of the packet, as we have assumed, will be 10.168.1.3. Right? So destination IP address falls in the local subnet of router B. Right? And what is that local subnet? That local subnet is this one. Let's call this local subnet as subnet A, which is 10.168.1.0/24. Right? So you can apply the IP address mathematics, and you can see that destination IP address specified in the packet falls in the local subnet A of router B, and therefore router B propagates the packet to the destination C via L2 routing. So we have just done the recap here, because what we will going to discuss next actually relates very closely to what we have discussed in this slide. So let's take another scenario now. let us say that destination IP address in the packet is 122.1.1.1, and this IP address is actually the loopback IP address of the destination machine C, right? So let us suppose that the router A receives a packet from elsewhere in the network with destination IP address 122.1.1.1. So using usual L3 routing, let's assume that the packet will reach eventually to the L3 router B, right? Now again apply the concepts of L2 routing and L3 routing. So L3 router B, when receives a packet with the destination IP address 122.1.1.1, it will inspect the destination IP address of the packet and see whether the destination IP address of the packet belongs or falls in any of its local subnet. Now in this case the answer is no. The destination IP address 122.1.1.1 do not belong to any of the local subnet of router B. It means that the router B knows that the packet belongs to some remote subnet, right? And therefore router B decides to use L3 routing in order to forward the packet to the next host machine. Now given here is the L3 routing table for the router B, and it will look up the routing table entry in its routing table using destination IP address in the packet as a key, and you can see that this entry in the routing table will match. So L3 router decides to forward the packet towards the next hop IP address 10.168.1.3, that is this IP address, and outgoing interface is Ethernet 1. So destination IP address in the packet falls in the subnet 122.1.1.1/32, which is actually a remote subnet with respect to router B, right? And therefore router B propagates the packet further to the destination node C via L3 routing. So you can see that L3 router B further propagates the packet to the destination machine C using L3 routing only. And the packet content when the packet traverses from router B to destination machine C looks something like this. That is, source MAC address will be equal to the MAC address of Ethernet 1 interface of router B, and destination MAC address will be the MAC address of destination machine C. Source IP address could be anything. It is irrelevant here that what is the source IP address of the packet, and destination IP address in the packet is 122.1.1.1. So the point here to note here is that instead of L2 routing like in the previous example, here L3 routing is being used in order to propagate the packet from L3 router B to the destination machine C. Despite the fact that destination machine C and L3 router B shares a local subnet 10.168.1.0/24. So when does the router decides whether it has to propagate the packet further using L2 routing or L3 routing is the concept that we should understand here. In the previous example, the destination IP address specified in the packet actually falls in the local subnet of L3 router B, and therefore router B decides to propagate the packet further using L2 routing. But in this example, the destination IP address specified in the packet do not fall in any local subnet of router B, and therefore router B concludes that the packet belongs to some remote subnet in the topology, and therefore L3 router B stick to L3 routing in order to further propagate the packet. So you can see if So the end result is that if destination IP address is the loopback address of destination machine, that is, if the destination IP address that is specified in the packet is actually the loopback address of destination machine, packet never undergoes L2 routing. You can see that the packet is delivered from the source machine A to B using L3 routing, and then from machine B to C it is delivered using L3 routing. So I have not discussed anything new here, just stick to the definitions that we have discussed when we discussed L2 routing and L3 routing, and you really will not have any doubts or questions regarding this. So I am discussing one more routing example here in order to make the point clear. So in this diagram you can see that machine D, machine E and machine F, all the three machines are present in the same local subnet. And what is that subnet? The subnet is 12.1.1.0/24. That is this subnet, right? Including the L3 router, which also shares the same subnet on interface IFR. Now, machine D, E and F can communicate with each other using destination IP address as 12.1.1.x using pure L2 routing only, right? So we have already discussed this concept that all the machines which are present in the same local subnet can communicate with each other using L2 routing, right? So machine D, let us see the example here that machine D can actually send a packet to the machine E using destination IP address as 12.1.1.3. If the machine D chooses the destination IP address as 12.1.1.3, then it is a case where source machine and destination machine both are present in the same local subnet, and therefore using pure L2 routing only, machine D can deliver a packet to the machine E. But now let us change the scenario a little bit. So let us try to understand that can machine D send a packet to machine E using destination IP address as 122.1.1.1, where this IP address is actually the loopback IP address of the machine E. So let's see how. So when machine D tries to send a packet to the destination IP address 122.1.1.1, machine D would know that this destination IP address do not fall in any of its local subnet. Machine D only has one local subnet, and that is 12.1.1.0/24, and clearly the destination IP address to which the machine D is trying to send a packet is clearly do not falls in this subnet. Therefore, machine D decides that it is not a case of L2 routing, but it is a case of L3 routing. Therefore, D is trying to send a packet to a remote subnet. Hence, D can send a packet to E using destination IP address as 122.1.1.1 using only L3 routing, and for that, D should have the following L3 routing entry in its routing table. That is, in order to reach this remote subnet, the next hop IP address is 12.1.1.3 and the local outgoing interface is IFD. So the final conclusion is that if destination address of the packet is actually the loopback address of a destination machine, packet never undergoes L2 routing even if the communicating machines are physically present in the same subnet. So you can see in this example that machine D and machine E are actually present in the same physical subnet, and that same physical subnet is 12.1.1.0/24. But even then, if machine D wants to send a packet to the machine E using destination IP address as loopback address of the machine E, then machine D has to use the L3 routing. And the simple reason for this is that loopback addresses are actually the subnet with one machine in it. So this was all about routing using loopback IP addresses.